Okay, guys, so we're talking about radicals today. And radicals, as you guys know, are the opposite of a square or an exponent function, right? So, as part of the warm up, it said, hey, can you guys list some perfect squares, cubes, and fourth powers or quartic powers? And what I did was I went ahead and listed these out. Now, guys, you should know a lot of the cubes and squares. It'll make your life a lot easier if you remember some of those. But the fourth power is really, if you don't remember all of them, I only wrote out the first five. Um, but those you can rely on your calculator to kind of help you find. Okay. So the next section talks about what are the parts of a radical. So the parts of a radical are the index, which is the number out here, and that represents what power you are doing the opposite of. The actual radical itself, right? The notation for that. And then what they call the radicand, which is the number inside of that radical, right? So if there's no index or no number listed, it's assumed to be a square root, which is an index of 2, right? So a lot of the numbers below, you kind of know these already, right? So the square root of 16 is 4, and often we were saying plus or minus 4, right? Same with 121 is plus or minus 11. 289 is plus or minus 7. Ooh, fraction, tricky one, right? But don't think of it as a fraction, just think of it as two numbers. So the square root of 4 was 2, and the square root of 25 was 5. Okay? And these all have that plus minus sign because the index or that root is even, because this is, remember, an imaginary 2 as your index. Now, all of those numbers are ones that you know, and I don't know why it's just a 7, it should be 17. Okay? But we know that those roots end up being plus or minus usually, especially when we do the operation, because we want to show that, yeah, negative 4 times negative 4 is also 16, and so is 4 times 4. Okay, so we note that even indexes that are positive have two roots. Okay, and what about if you have an odd number? Okay, so remember, 8 is 2 to the third power, so the cube root of 8 is 2. And the cube root of 343 is 7. Cube root of negative 125 is going to be negative 5. And then again, that fraction trying to throw us off, but it's still just the negative. Cube root of 1 is 1, and the cube root of 27 is 3. Okay, so now notice these odd exponents, which did not cancel out the negative, give us these radicals that also keep the signs. Okay, so there's only one solution for odd radicals, right? Odd indexed radicals. So that's just one thing to keep in mind. If it's odd, it's going to keep its sign. And if it's even, it's only allowed to be positive. There are no solutions if you are taking the square root of a negative, right? So evens don't ever like to go with negatives, okay? Now, we can look at some of these fourth power ones as well, just to see kind of what the numbers look like. So the fourth root of 1 is just 1. 2401 is actually 7 to the fourth power. And again, you can see these numbers are actually really big for that. And the next one is 8, okay? And the last one is 3 over 2. Now, guys, once again, I'm not asking you to do these in your head. You'll be able to use your calculator to find those, and there is a nice button on your calculator that has a symbol like this. You have to use the control key to do that. So you would fill in whatever that number is for n. So in this case, it's 4, and then you can fill in the blank on your calculator. Okay, all right, let's look at the next section where we talk about simplifying these radicals, okay? So here, we're going to try to break these numbers down to simplify the radical. Now, a lot of you guys will just type it in the calculator and try to get a decimal. You got to break that habit, guys, okay? We're not talking about decimals. We're just trying to see if we can break them down, okay? So what I'm going to show you is using your calculator to help you with this. And what you're going to do is go to your calculator, and in the calculate section, you're going to go menu, look for number, and factor. Okay. And what it does is it breaks up the number for you. So if you go menu number factor on 117, okay, it's going to spit out something that looks like this. It's going to say, hey, that is 3 squared and times 23. Okay. And how we break this up is this is a square root. So I'm going to write this out the long way. 3 squared, there's two threes. So 3 times 3 times 23 makes 117. And since this is a square root, it has an index of 2. So I need any pairs, two of a kind, will come outside. So 3 times 3, I'm going to take out a 3, and this leftover 23 still goes back inside of that root. Okay, and this is broken down. Okay, so this section in black comes from your calculator, and then you write it out kind of a long way, separate out all the threes so we can get an easy count of them. Okay, so let's do the same thing with the next one, that 320, and see what we get. So if you did the factor trick on 320, it's going to tell you 2 to the 6th power times 5. And we're going to write this whole thing out real quick. So I've got 6 2's, 1, 2, 3, 4, 5, 6, and a 5. Okay. And let's break this up. Again, this is a square root, so we need everything in twos. So I see 1, 2, 3 pairs of twos, right? So I'm going to take out 3 2's. 2 times 2 times 2. And this 5 goes back inside my root. And don't forget about this 4. Remember, he was outside, so we're going to bring him down as well. So let's see what we've got. 4 times 2 times 2 times 2 is going to be 32. And then the square root of 5 is still hanging on there. Okay, and that is my answer for that one. Okay, now same processes for the next couple, except you'll notice these are cube roots this time, right? They have that cube, which means instead of taking out 2 of a kind, we take out 3 of a kind. So still, we're going to use menu number factor to break up our number inside. And let's see what we get as we do this, right? So with 48, menu number factor, and you're going to get 2 to the 4th power times 3, which means we've got 2, 2, 2, 2, 3. And I can take out 3 of a kind now, 3 at a time. So here we go. These 3 right here are going to take out a single 2. These other 2 guys are going to have to go back inside here, 2 times 3. And oh yeah, that 2 can come outside as well. Okay, so 2 times 2 outside is going to make a 4. 2 times 3 inside is going to make a 6. And this is a cube root. We should always be careful to note what kind of root this was. So we've got 4 cube roots, 6 as our simplified answer. Okay, all right, why don't you guys try number 4, and then I will post the answer for you in a second. So go ahead and pause and do that. Okay, so I'm hoping that you got 9 cube root 4 as your final answer. So you can take a second again, you can pause the video and get this down if you missed it for some reason. But it should be pretty straightforward now how we can break down radicals. Okay, let's look at a couple more examples on the other side. Okay, so once again, we've got some silly examples here as well, but we can do just one or two more just to make sure that we've got it down. Okay, so number 6 is kind of a goofy one. They just wanted to remind you that that negative sign is going to come outside. That is the same as negative 6 cube root of 2. Because the 2 doesn't actually break down, but the negative can slide outside because remember, this is an odd exponent or an odd index, which means the sign stays there. Okay, remember, if this was even, it would actually have no solution. All right, let's look at some of these with variables. We can do these this exact same way, right? The number portion, we'll use that factor tool from your calculator and break it up. So then 32 ends up being 2 to the 5th power. And we got x to the 4th, y to the 9th. Okay, and we could write these all out kind of the long way and just see where we end up. So I'll zoom in a little bit so we can write nicely in here. So I've got 5 2's, 1, 2, 3, 4, 5, 4 x's, 1, 2, 3, 4, and 9 y's, 1, 2, or sorry, I'm writing x's again. 1, 2, 3, 4, 5, 6, 7, 8, 9 y's. Okay, and it can be kind of tedious to write out all 9 of them. And so there are some shortcuts I'll talk about in a minute. Okay, so 1, 2, two groups of 2 I'm going to take out, 2 times 2. And I know I have a leftover 2, so we'll put that in later. And 2 x's, so we've got x times x. And we've got 2, 4, 6, 8 y. So 4 groups of y. 1, 2, 3, 4. And a leftover y. So what's left over in my root? That 2 and a y. And let's just clean up what we had out here in the front and make it all nice and pretty. So 2 times 2 makes 4. X times x is x squared. 4 y's, y to the 4th power, and the square root of 2y. Okay, and there you go. There's your simplified form. 4x squared, y to the 4th, and square root of 2y. Okay, so just remember, guys, everything for square roots has an index of 2, so it comes out in pairs. For cube roots, everything has to come out in groups of 3, right? So you can sometimes shortcut a little bit if it makes sense to you, okay? So for example, let's look at number 11. 216 is going to factorize, and we're going to get 6, sorry. 2 to the 3rd, 3 to the 3rd, okay? And what we'll do is we've got m cubed and n to the 6th. Well, we could write this out and see kind of how this looks. 2, 2, 2, 3, 3, 3, m, 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 and n, 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 n. And you can see I've already actually started kind of grouping these by 3's because I already know I'm trying to get groups of 3. So 2's will come out, 3's will come out, m will come out, n and n will come out. And I can kind of put all of this together. 2 times 3 makes 6, m, n squared. And there was nothing left, so I don't even have a radical left. I'm just done with that. Okay, so this is the general idea of breaking down a radical. Okay, there's nothing super duper fancy beyond that. Now, some of these guys, you'll notice the numbers get a little annoying. Like number 13, got 21 y's, right? So we can kind of simplify this a little bit, and I'll show you how. So I'll do the same thing. So I'm going to start actually by noting this negative sign. I know that my final answer is going to be negative at the end, okay? But 64 is going to be 2 to the 6th power. X is to the 10th power still, y is to the 21st. Now, I really don't want to write out 21 y's. That's going to be a pain. But what I can do is I can say, hey, I know that 6 2's in groups of 3, that's 2 2's of 3, 2 groups of 3, right? So this is 2 groups of 3. 10 right? How many threes can you take out of there? Well, three, right? Three groups. That would make 9, and I have one left over, right? And then 21 is how many groups of 3? If you did 21 divided by 3, you would get 7 groups, okay? So let's see what we did here. By coming up with what groups we take out, that is 2 groups of 3. So 2 groups of 3 for 2 again means 2 2s coming outside, no leftovers. I've got 3 groups of x's, so 3 x's, 1, 2, 3, and 1 leftover. So inside my root, I'm going to end up with a single x in there, so I'll make a note of that. And then 7 groups of y. I'm just going to shortcut. I'm going to write y to the 7th. Square root, remember that x inside. And I'll clean it up. 4x to the 3rd, y to the 7th, cube root of x. Okay. Remember, whatever root it is, you got to follow through with that. It needs to be a cube root all the way through. Okay, don't forget that this was a cube root. Remember this negative sign? I mentioned it at the very beginning. This answer is negative because that sign comes outside. Okay. See if you guys can apply the same thing to number 14. Okay, I'm going to pause and let y'all do that one. Okay, so negative 81 would have factorized down to 3 to the 4th power, right? So once again, I can take out a3, and there would be a 3 left inside. Notice that p does not have enough pieces for me to take out. I'm going to just have p squared still back inside. And then q to the 12th is actually 4 groups of 3. So we'll take out q in 4 groups, no leftovers. And don't forget this is a cube root. And of course, negative, guys, make sure that you bring that negative along with you out here. There's your answer right there. Okay, so remember, you could write them all out. You could write out all 12 q's and circle groups of 3, but you can also do 12 divided by 3 is 4, and that means q to the 4th comes outside. Okay, but you got to be careful about the remainders because the remainder stuff goes all back inside of there. Okay. Okay. Now, guys, this works with just about anything. Okay. Like number 17's got some big numbers, but still completely doable. Okay. Very easy example for you guys here. So what you'll see is like, you're like, hey, 625 is 5 to the 4th power. Got c to the 23 and d to the 11. If I just divide all of these by the 4, right, we know that 5 is going to come outside. 23, that is 20, right? 4 groups of 5, or sorry, 5 groups of 4. And there's 3 remaining, right? So 23 divided by 5 is 4 with a remainder of 3. Okay, so when I take this out, I'm going to take out 5 C's, and I'm going to have to put what? 3 C's back inside of here. Okay, and if we continue, we do D as well. And you'll see it's going to be very similar. So now I have 11. So that is 2 groups of 4 and 3 remaining, right? So 11 divided by 4 is 2, remainder 3, right? You can fit 2 4s in your 11. So we're going to take out 2 D's and have 3 D's left over in here. And kind of crammed it all together, but there's your answer right there. Okay, so guys, that is simplifying radicals in a nutshell. Make sure that you practice this, and good luck and happy studying.